So today we're going to learn how to multiply a monomial times a polynomial. And the thing about monomial times polynomial, we actually basically know how to do this already. With a combination of the exponent laws that we just learned and the distributive property, we can actually do a monomial times a polynomial quite easily. We're going to be using this process when we get into polynomials times polynomials in the next video as well. Okay, so let's take a look at our first example. We have 6n times 7n plus 8. 6n times 7n plus 8. So like I said, we're going to be using the distributive property here. So this is 6n times 7n and 6n times 8. One thing we need to remember, those are invisible exponents on our variables. Okay, so if we do 6n to the first times 7 to the first, we multiply our coefficients. So 6 times 7 is 42. And n to the first times n to the first, that is n to the second. Multiply 6n times 8, that's 48n. Nothing too crazy. All right. Now we can also have multiple variables in it. Let's take a look at 2 examples where that might be the case. This one where we have 5x to the fourth times 8x minus 6y. Okay, so invisible exponents on the x and the y, and we distribute. 5x to the fourth times 8x, let's multiply those coefficients, times 5 times 8 is 40. And then x to the fourth times x to the first, we need to add those powers. This becomes x to the fifth. Okay, so we need to multiply our coefficients again. 5 times negative 6, that's negative 30. And so we have to think, is x to the fourth and y to the first at the same base? The answer is no, that we actually don't need to do anything to combine them. They are already in the form they need. And so all we're going to do is write them again, x to the fourth, y to the first. Okay, as an example, when we multiply them, our variables don't change. So take a look at another one that requires multiple variables. We have 3n cubed m squared times 4n minus 9m n to the fifth. So let's go back and think, are there invisible exponents here? Yes, n to the first and m to the first. Process remains the same. We're still distributing. This leading term is quite large now, larger than we've seen before. But nothing really has changed. This is just a product rule problem. What is 3n cubed m squared times 4n to the first? This is our product rule on the exponent laws we just learned last week. Okay. So 3 times 4, that is 12. N cubed times n to the first, let's add those powers, that's n to the fourth. And there's nothing else to match up with m, so that remains m squared. Well, now it's a product rule problem between 3n cubed n squared and 9m n to the fifth. Okay, I kind of covered up my own invisible exponent there. I'll put it back. So 3 times negative 9, that is negative 27. N cubed, n to the fifth, add those powers. These are the same base, n cubed into the fifth. That is n to the eighth. And then m squared times m to the first, add those together. 2 plus 1 is 3. Okay. So that is m cubed. All right. So far in these first 3 examples, we've seen a monomial multiplied by a binomial. But there's no reason it has to be a monomial multiplied by a binomial. It could be a trinomial. It could be a polynomial of 4, 5, 6 terms. We'll just focus on a trinomial for now. Okay, so we have a mono by trinomial. That's what we're going to work on next. This next example, we'll just deal with one variable for now, where we have excuse the bell, we have 5k squared times 3k squared minus 3k plus 4. As you might imagine, we're still multiplying, distributing to the 3 terms. And so 5 times 3, that's 15. K squared times k squared, 2 plus 2 is k to the 4th. 5 times negative 3, negative 15. K squared times k to the 1st power, that's k cubed. And 5 times 4 is 20. There are no other k's, so this is k squared. So monomial by a trinomial is not really any different. We'll do one more example together. This one is going to be a monomial times a trinomial that incorporates 2 variables, and I'll have you do one on your own. Okay. We have 6a times 7a squared plus 3ab plus 4b squared. Close out parentheses. And still distributing. 6 times 7 is 42. We have an a to the first in our leading term. So a to the first times a squared, that's a cubed. A cubed. 6 times 3, 18. A to the first times a to the first, this is a squared. B remains unchanged. And finally, 6 times 4 is 24. A, there's nothing to multiply the a's by, so that remains the same. And this b remains as it is. So that is b squared. And 42a cubed plus 18a squared b plus 24a b squared. Let's take a look at one more. This one you're going to do on your own. We have negative 7m squared times negative 3m squared plus 3mn plus n squared. All right, do this one on your own and then move on to the next video.